Okay, so this is a topic 11, basic scripting and system administration. So this is kind of the kind of a high level overview of things that you would want to be dealing with in terms of system hardening at the operating system level. So assuming that we've got something like like an operating system case we'll be talking about is Linux. What are some of the things you would want to do to improve and tighten up the security on those systems? So this would go a couple things to look at, on the Security Plus book, Chapter 13, and then also there's some interesting. Once again, NIST has some interesting stuff around generalized guide to general server security, as well as enterprise patch management and technologies. Once again, NIST provides some very good background of kind of an overview of things to be taken into consideration. So the basic mechanics of this stuff is that we're talking about how do we configure the IT environment to conform to a consistent standard for technology. So you want to use approved authentication authorization mechanisms. You want to disable unessential services in OS and server application software. You want to identify what is the baseline, what is a typical behavior, and then to establish the baseline, and then monitor against that baseline. So, one of the key elements of this, the base, as a starting point, thing you need to do if you're a security person, is you want to harden, the key components of the IT architecture to reduce the risks of attack. So the things you can do is you can make adjustments on your operating system, on your network, and on your software applications. The thing to keep in mind as we look at this is that by default, um, security is not a given. All right. So the assumption should always be, has always needs to be, is that security needs to be applied. Security needs to be defined, and then applied, and then managed. Those are the three essential elements that any systems manager, a systems administrator, needs to take into consideration. Right? So in effect, from we look at it from OS perspective, there's a couple basic things you can do. And remarkably, this does not get done as near as much as it probably would need to do. But this is the basic things you need. So number one is identify and eliminate all non-essential services. By default, operating systems will come with virtually everything on them. You're seeing now with more modern implementations that is not necessarily the case now. In particular, with like Microsoft, which was probably one of the more notorious players in this game. Early versions of Windows and Windows Server basically had everything enabled, by default. Now you've actually got reduced profiles, but irregardless, the idea of identifying what are the non-essential services and then removing those, and reducing the attack profile down to the minimum level. Um, Patches and fixes, maintaining and managing um, the system, the application of patches. Patches are a given in systems, and what happens is the application. The expectation is that you know a a vendor will patch their systems, but it's up to the user to actually apply and implement those patches. So security updates on an ongoing basis. Password management is a key area that many times organizations are not as attuned to as they would need to be. So, the idea of being able to have weak, easily guessed passwords, regular changing of passwords, disabling of accounts after repeated login accounts. Those are all key things that need to be done with passwords. And a lot of times you'll see in postmortems of attacks that organizations will go back and they'll find that, oh, gee, there was, we had, X percentage of our passwords or policies were not enforced. All right. So then And then finally, unnecessary accounts. There's a lot of accounts that, by default, operating systems will put in that are behind the scenes, guest accounts, administrative accounts. Um, One of the big things about those, A, they're they're very well known, and B, they can be, they have long been targets for exploits. So the idea is identifying anything that's not necessary and then disabling it, removing it, documenting it as well. So a couple other things that it can be taken into consideration is particularly around file systems. Basically defining, making sure that you've got file systems protection, basically access authorizations like ACL lists, file permissions. Not everybody can see all data on the systems when you log in. Um, file system encryptions. Now the challenge with this is actually an important thing, but once again, when you encrypt something, you need to make sure that you can decrypt it. So things like key and key management becomes very important around this. So the question of when and where you want to apply encryption needs to be thought through. You can't just simply, you don't want to necessarily just turn everything on, because you've got to you have to maintain and manage the keys. And in addition to the keys, you also have to maintain and manage the data itself and the overhead associated with doing encryption. However, depending upon the environment, this can actually be a very valuable tool. So, logging. So we talked a bit about logging. The ability to log events and activities. Two things need to be done. Number one, you need to enable logging. Number two, you need to be able to capture logging and look at it on an ongoing basis. A lot of organizations will generate logs. Not as many will analyze logs on an ongoing basis. So logging and log analysis can be a very critical item. And then file sharing. The idea of basically being able to enable data to be copied from one system to the another um, was a default. Was something that can be established by default. The problem is though that it also is a pretty well known uh, attack vector. So controlling that, disabling any unnecessary, identifying, establishing policies around when and how file sharing should be established is a key issue as well. One of the challenges a lot of times with virtualization. So the idea is with virtualization is a very valuable, actually probably one of the major drivers, I would say, over the past 10 years. So this idea of you're seeing more and more and more organizations are basically reducing the numbers of physical systems, but increasing the numbers of virtual systems. And then conversely, cloud computing, which is all based upon virtualization as well. So you have one physical computer hosting multiple operating systems, controlled by something called a hypervisor, which actually controls all of the systems. From a security perspective, the idea of being able to, a compromise of a virtual machine um, could potentially mean the exposure of hundreds, potentially thousands of machines, of systems. So this becomes security applying to virtualization is very important. All right. So this is actually next couple of slides more deal with the basics of Linux and Linux configuration. So environment variables. The idea of what you can do is you can actually run you can actually Linux has a whole series of commands, a very rich command interface, one command line interface, which can actually be turned into scripts. So these are all examples around some of the functionality that you can do within that. So let's take a look at patch management. So we talked about the importance of patch management. It's that we define it as the process for identifying, acquiring, installing, and verifying patches from operating systems, software, and firmware. All right, and what you need to do is you need to correct functionality and problems of the OS, software, and firmware. They're there. they are identified on an ongoing basis. But the expectation is never that okay, we've fixed that problem. All right, so the idea of okay, we need to since we will never have a perfect operating system, the idea is okay, our next best thing is that on an ongoing basis we have a very strong process for identifying and applying this stuff. It can mitigate software vulnerabilities and reduce exposures on attacks, which is really the essence of what security is all about. So you've got a lot of this ability of creating of patch managing. It's not just simply it's not a tool. It's a combination of tools and processes and procedures to all combine together to to maintain and sustain a secure level set. Concept of a zero-day vulnerability. You've heard this. You may have heard this before. What happens is a lot of times as patches, as vulnerabilities are identified, because vulnerabilities are checked on an ongoing basis. As vulnerabilities are identified, what will happen is that the time between the um, vulnerability is identified and the time it is patched, and then it is announced that the patch is out there. There's a period of time around that. So what's been happening, but the concern has always been is that so usually what's been happening is a vendor will like Microsoft will be checking its code, it will find an error, it will patch the error, it will incorporate the patch into a set, and then afterwards it will announce that okay, here's what the vulnerability is. With the idea people will apply the patches. A zero-day vulnerability is one that a vulnerability is unknown to the vendor, and it gets exploited by hackers before the vendor can develop the patch for it. So this is actually we haven't seen many zero-day vulnerability attacks yet, but what's been happening is the window between the announcement of a vulnerability and an exploit of that vulnerability has been shrinking and shrinking and shrinking. So ultimately, this idea of a day may come when we will actually see a impactful zero-day attack is probably at some point um, downstream. So what you can do really with the zero-day vulnerability is you can't necessarily protect against that. However, what you can do is maintain your patch levels to the high enough level so you can perhaps reduce some of the vulnerability and some of the impacts around that. Yeah. So best practices, inventory. So this is really a list of the different things you want to do. You want to maintain an inventory of all the operating systems, um, what you've got running on them. You want a standardization, which is a critical part. The more standardized your operating systems are, the better opportunity you have to be able to maintain things. The more diverse the environment, the more challenging it becomes to maintain security patching. You want to identify all the controls implemented to assess and respond to vulnerabilities. You want to compare on an ongoing basis any reported vulnerabilities against what you have in terms of inventory. What is the exposure? Um, Ongoing basis, you want to assess vulnerability and likelihood of attack, and then apply uh, patches as in a organized fashion. One of the challenges you run into though with personal applying patches is the risk you can actually break something. You can break an application, you can break an operating system. So one of the challenges you need to, as a best practice, is to create a parallel environment, basically that looks like your production environment as a test bed, and then to apply all patches, into the testing environment, verification that everything works, and then move them into production. So there's a whole life cycle associated around these things. One of the biggest challenges is to try to apply application of an emergency patch, um, which could have potentially a unexpected side effect of actually creating more disruption in an organization. So this becomes a being proactive, creating a environment, and then managing that environment is very important. Information on network hardening. You want to update your hardware and software. Basically network hardening is not unlike operating system hardening. All right. So updating hardware and software ongoing basis. Password protection, identification of anything. It's got a like an administrative password in it. Managing that. all devices, almost every device has some sort of administrative functionality within it, which needs to be accounted for from security. Also, disabling any unnecessary protocols and services, and then also, making sure that any ports that are not needed are turned off and potentially eliminated. If you don't need something running in the machine, you should turn it off. Wireless security, the idea of making sure that you design a wireless security so it's in a protected domain, and in addition, you're running with the highest versions of the WPA of using WPA security, which is the recommended version, recommended security. Also, restricted access, making sure that you prevent unauthorized users from, um, you know, restricting your access and access paths through the network. So using things like network address tables and ACLs and VPNs and things of that nature, making sure you've got a layered network architecture to protect yourself. Software application. So there's some guidelines here taken into evaluation. So things like web servers, in particular, web servers should be configured to be web servers and not multifunctional. You don't want to put necessarily, databases onto a web server. Web server should be designed specifically with, uh, implemented with things like SSL or TLS. You want to make sure you're managing the web server logs, make sure you don't have any extraneous software, monitoring activities on web servers. Email servers, basically uh, disabling anything non-essential and making sure that only it's configured to be an email server. Same thing with FTP, in particular FTP, anonymous FTP, which was a feature that was baked into FTP, which is over time has really organizations have moved away from it. However, it's still there. It needs to be disabled as a best practice. And then with DNS, making sure that all security around DNS, secured access to the internet service by blocking port 53, restricting access to specific servers, making sure that the software is updated on an ongoing basis. And that is it for topic 11.